So one of my favorite parts of my job is throughout the year, I get to hear customer stories. I get to hear about the success they've had with VMware Cloud and AWS. And one of them that came across earlier this year was hearing the story about Phillip 66 and Rick's team and what they were able to accomplish. And when I read this thing, I was like, wow, this is incredible. This is the kind of story we need to be able to share with others. I feel like this would resonate really, really well with other folks. And Rick was kind enough to be willing to join us here at reInvent, share the story of what they accomplished and what his team accomplished. And I think you will find it fascinating, and I hope you will find some of the lessons learned and some of the real details of a real customer experience fascinating and helpful for you on your journey as you look at moving into the cloud. Hi everybody, my name is Andy Reedy. I lead the product team at AWS, which is dedicated to the VMware partnership. So I work on services like VMware Cloud on AWS from within the EC2 engineering organization. I'm joined by Rick Snell. Rick is the CTO of Phillips 66. And we're going to share with you a little bit about their journey, about some of the challenges that they overcame and how they used VMware Cloud and AWS to accelerate some objectives that they had within their organization. So I'll lead off and just give you a little bit of a background on VMware Cloud and AWS, just level set, make sure we all understand kind of the core technology bits, because Rick is going to dive a little bit deeper into some of the specific components that they went through. I want to make sure you have just a basic understanding and really can follow along as he goes through their bit. We will be around after the session. We have a pretty decent amount of content, but as soon as we finish, we're happy to stand around here in the front and answer any questions that you may have. So please, if there's something specific that we didn't cover or we didn't dive into that you'd like to know about, we will stay in this room until they give us the boot and kick us out. So feel free to grab us afterwards if there's something that you want to chat about. So again, just to kind of level set, start off, what is VMware Cloud and AWS? So VMware Cloud and AWS is a managed cloud service that allows you to run the VMware stack directly on AWS bare metal infrastructure. So about 7 years ago, AWS started working on the Nitro platform. If you've had any other sessions or got a chance to learn about Nitro, it's a really incredible platform. It allows us to take a lot of the virtualization components that traditionally were in software, bring those into the physical hardware. So we build physical cards that are running in these servers that allow us to essentially remove the hypervisor bits completely from the software piece and allow software to run directly on the bare metal. So like, for example, a VMware hypervisor can now run directly on AWS bare metal instances. So we launched this technology, and VMware was one of the very first customers to take advantage of it, and we built the VMware Cloud and AWS service with it. So VMware Cloud and AWS allows you to run the VMware hypervisor, the VMware software-defined data center stack directly on AWS bare metal. It is a fully managed service. So this is a key piece that a lot of folks, it takes just a minute to really wrap your head around the value proposition of this. But with it being a fully managed service, VMware takes care of all the patching, updating, and upgrading. So traditionally in an on-prem environment, there are teams that are focused on actually having to manage the ESXi versions, NSX versions, vSAN, actually do the patching and upgrading. And especially if you have a large environment, I talk to customers and they say, yeah, we have a team of folks. This is all they do all day long is patch VMware environments. And our environment is so large that by the time they're finished, they essentially start over and are having to patch again. With this being a cloud service that VMware manages, VMware is responsible directly for patching, updating, and upgrading the environments. And since it is running in an elastic environment, they can do some really cool things. So for example, rather than having to take a host and put it in maintenance mode and pull it out of production and then update it and put it back in, you can simply just add a new host into the environment that's running the new version and then pull the old host out of the environment. So you take something that's like a traditional VMware environment and you now marry that with the cloud and you take advantage of the elasticity and the capabilities within the cloud. I briefly mentioned some of the components, but there's ESXi, there's vSAN, there's NSX. VMware bundles these together and refers to them as a software-defined data center. You may also hear kind of the VMware Cloud Foundation bits be referenced. But these are the components that are running within VMware Cloud on AWS. And it's all running on the AWS global bare metal, or on the AWS infrastructure, and it runs on bare metal instances. It is important to note, VMware is not running a nested virtualization. This is not Vert on top of Vert. This is the ESXi hypervisor running directly on AWS bare metal. One of the key advantages of this that we see is this is the same software that your engineers, your administrators, perhaps you are familiar with running in your on-prem environment. So it's not like you have to learn something new or suddenly you're taking somebody who's worked for 15 or 20 years in VMware and they're now just kind of thrust into the cloud space and they have to figure out how to do the same things they've always done in a new platform. You log into vCenter and you manipulate vCenter just as you would on-prem. If you can create a virtual machine on-prem within vCenter, you can do the same thing in VMware Cloud and AWS. So familiar tooling. Also, a lot of the scripts that are available or that you've used on-prem, so if you've built out your own automation or your own tooling or use third-party off-the-shelf products, if they talk to the vCenter API endpoint, they will function here as well. So it allows you to basically be able to move from your on-prem environment into the cloud without having to deal with a complete replatforming exercise. You're essentially rehosting the environment that you were running, and you're being able to do that within the cloud without having to completely relearn everything and start over. The interesting thing too with this software-defined data center running within the AWS environment, it is also connected directly into a VPC, into your VPC. So one interesting piece to note is this is not, if you were to look in your AWS account, you would not see a bunch of ESXi hosts running as EC2 instances within your AWS account within your VPC. When you go to deploy VMware Cloud and AWS, you log into a VMware Cloud console. You are able to provide all the input parameters that you need to deploy an environment. VMware deploys this within an account that they own and operate. So this is running in an AWS account that VMware owns and operates. You don't directly get into the AWS account. You can't see it. You have no access to it. So VMware is operating this as a service on your behalf. So it's all within an account that they have. But they connect the software-defined data center into your AWS account, into your VPC. So one of the input parameters that you provide whenever you're provisioning the service is you say, here's my AWS account that I want you to connect this SDDC to. And you'll notice kind of the NSX connected to the Elastic Network Interface. That is that connection point. What this allows you to do is actually have virtual machines that are running within the VMware environment, and they're able to talk to resources that are sitting within your AWS account. So imagine if you had EC2 instances or you had private link endpoints or any of those types of things sitting within your AWS account, those VMware virtual machines running inside a VMware Cloud and AWS would be able to communicate with those privately without having to go back out over the internet. So this allows you to treat these VMware VMs just as you would other resources and access private resources like S3 buckets or EC2 instances that are running within your VPC. And another piece of this is, on the left-hand side there, you'll notice vCenter in your on-prem data center environments. One of the cool things that VMware has built out of this is the hybrid cloud extension, hybrid linked mode. This allows you to connect your on-prem vCenter environments and your AWS, VMware Cloud and AWS environments together so that you can manage both of those within a single pane of glass. So if you're looking in vCenter, you kind of see your tree of resources. You're able to see VMware Cloud and AWS just as another data center, just as you would if you had multiple data centers on-prem today. Allows a lot of just seamless management. You're not toggling between your VMware Cloud and AWS vCenter and your on-prem vCenter. You can connect those things together and manage it all within a single pane of glass, which really makes it super easy to be able to manage these environments. Another kind of cool technology that VMware built as a part of this is their hybrid cloud extension, or HCX. You'll hear Rick mention this. Quite honestly, this is some of the magic, really, with accelerating migrations to the cloud. HCX allows you to do some cool things like actually extend layer 2 networks from your on-prem environment into the cloud environment. And what we've actually learned is this is one of the hardest parts of the cloud migration, is having to re-IP your VMs, especially if you have a lot of older legacy workloads or workloads that are commercial off the shelf that you don't own. You would think, hey, in this day and age, you don't have to worry about IP addresses, everything is DNS. Well, it turns out there's a lot of things tied to IP addresses. There's firewall rules, there's systems where, especially in large complex environments, they're just things that care about IP addresses. I know we would all like to think it doesn't matter, but it kind of does. And so with HCX, being able to actually take these workloads and move them from point A to point B without having to re-IP them is super powerful, and it allows you to accelerate and migrate really, really quick. And that really, really quick part is kind of the main reason that we see customers using VMware Cloud and AWS. So I get this question a lot, like, why would I want to use VMware Cloud and AWS rather than just going and refactoring and building directly into AWS itself. Like, why would I add this component in there? And the answer is speed. If you have a compelling event, if you have some reason to move quickly, that is the number one reason that I hear customers come to us and want to talk about VMware Cloud on AWS. I have a data center evacuation, I have a contract that's expiring, I have a server refresh where my servers are going to be out of support and I have to replace them. So I have a choice to make. I either have to spend a lot of capital and buy new servers, or I have to renew this data center contract for another 3 years, and that's not necessarily an investment that I want to make right now. There are even other compelling events. We talked a year ago about the situation in Ukraine, where there were financial institutions in Ukraine that were really worried about their physical environment and the safety of that physical environment, being able to protect that data. And we had customers in that situation actually evacuate entire data centers in a weekend, the entire thing. And if you talk to a lot of customers, and the concept of moving an entire data center in a weekend is terrifying. This is something that normally takes months for folks to do, and they were able to do this in an entire weekend. So the main reason that I hear people wanting to use VMware Cloud and AWS is speed. If I can lift and shift, if I can get out of that physical data center environment, get into the cloud, that buys me a lot of time to figure out how do I want to leverage the rest of the native AWS services. Do I want to extend those applications and have them consume those native AWS services in a bespoke basis, on a one-by-one basis? Am I going to rebuild some of those applications completely and move them into native, or am I going to move those applications into a SaaS solution? Those things take time to analyze and figure out what your strategy is going to be. If you're up against the clock, if you have a contract date or some kind of renewal date, it's hard to make those decisions super quickly. And so being able to move into something like VMware Cloud and AWS and get out of that environment allows you that time to figure out what is my strategy for my workload modernization, what is my future plan that I'm going to end up doing with these things. And ultimately, that's a major use case. The second use case that we hear a ton about is disaster recovery. Disaster recovery it's wild. I've had so many customers come to me and they say, hey, we had a situation where we had an audit, or we had our board got involved, and basically we're very unhappy with our current DR strategy. We went in and we ended up using VMware Cloud and AWS, or we used a VCDR, which is a capability that VMware has built on top of AWS. And within 24 hours, we had a disaster recovery solution in place, and it was working. Interestingly enough, I had a reInvent talk a couple years ago where I had a customer come on stage. These folks had done a disaster recovery. They were setting up DR, and they were using VMware Cloud and AWS. They did a test where they actually failed over and ran their workloads in VMware Cloud and AWS. They were going through all their validation pieces, and they were like, wow, this is a lot faster than our on-prem environment. We should just leave this. And so they ended up, they did a failover test for DR, stayed in VMware Cloud and AWS, and then made their on-premises environment the actual backup to that. So DR is another really compelling use case that we see a lot of folks use. It comes in very, very handy if you have kind of like old DR environments or no DR environment, and you're having to maintain that equipment. I mentioned earlier the patching, updating, and upgrading. Talk about undifferentiated heavy lifting. If you're having to patch a bunch of software, replace failed hardware, or a power supply or a hard drive in an environment that's your DR environment, like we're spending engineering time or administration time working on a piece of hardware that's sitting there burning electricity or heating the air for no reason other than just to be a backup. That's a great use case to be able to take advantage of something like VMware Cloud and AWS or the VCDR capability. So I want to hand this over to Rick and have Rick talk about their story. I mentioned the piece about speed and the criticality, the scalability of VMware Cloud and AWS, being able to scale up and down as you need it, and really that flexibility. I hope you find this as fascinating as I did. I was so impressed with not only Rick and his team, but the company. As I learned more about Phillip 66, I was blown away. I think when you hear about some companies, you think, oh yeah, I've heard this name before. This is a pumps and pipelines company. I get it. And then the more I talked to Rick, I was like, wow, these people are doing so much more than I had an appreciation for. And I was totally blown away by their commitment to safety and just innovation and the things that they are doing and how much they are embracing innovation and technology. Super impressed. Rick, thank you also for taking the time to share this with us, and I'll hand it over to you and have you run from here.
Great, thank you. All right, thanks everybody for being here. It's 8:30 in the morning. I know it's pretty early for most, but I want to start out and really talk about who Phillips 66 is. Just a brief overview on Phillips. So we're a fully integrated downstream provider, and for us, Phillips 66 is, we do a lot. So we are a Fortune 20 company headquartered in Houston, Texas, and we have about 13,000 employees. So if you look at our lines of business, we have 4 lines of business. Probably most of us think of Phillips 66 as refining, but as you can see up there, we have about 1.9 million barrels per day capacity within our refineries. On the midstream side, we have about 72,000 miles of pipe in the ground. In chemicals, we partner with CP Chem. We're a 50-50 partnership there, and we have about 28 locations and 2 research facilities. And then in marketing specialties, we have about 10,000 branded outlets for our products. So we started our digital transformation in 2017 when we became a cloud-first company. And so for us, that said, get everything into the cloud as fast as humanly possible. Fast forward to 2023, we have about 98% of our identified workloads in the cloud today. And so we use the power of the cloud to really accelerate and work with the business and partner with them on all sorts of innovative projects. So when it came down to our journey, I brought this quote up. We were in an acquisition last year, and we had 1 year to fully integrate our company. And so from an infrastructure perspective, that's the first thing that has to come across. And, everybody said, this is going to be impossible. You guys don't have enough time. You got to make it happen. So with VMware Cloud, we actually did make this happen, and I'm going to go through that journey with you. So a little bit about how we understood VMware Cloud from the beginning. So back in late 2020, 2021, we had a series of pretty impactful outages in the cloud. And so we started to rethink about our architecture and say, how can we do this better? So our executive sponsor is David Brown, and he came back and said, you guys are thinking about this wrong. We came from an old data center perspective where you do east and west, data center 1 to data center 2. But what we didn't do is really architect it well using availability zones. So instead, we changed our philosophy and said, we are going to use availability zones to the max. So in East 1, we use all 7 to protect our stuff. The energy industry is, we'll say, very conservative in the way that they do a lot of their applications. We have a lot of legacy apps on Windows, and it's very difficult to protect those because they were not built with HA in mind. They're not built for high availability. So how do you protect those in a single AZ? You really can't. And so VMware Cloud came up, and we said, that's where we're going to go. So for us, when we look at VMware Cloud, we kind of use it in a multitude of different ways. So for our production workloads, we use the stretch cluster. So that's active-active across multi-AZs, and that gives us a lot of protection for our Windows apps. And specifically the Windows apps I'm looking at here because those are the ones that are really legacy off-the-shelf type of apps. Non-stretch, just regular old ESX cluster, we use that for our test of dev. We can have outages there, and we're okay with that. When we started getting to VMware Cloud, we were able to reduce our footprint, and so that helped on our licensing cost because we were able to get some efficiencies that we weren't having on EC2. And then we improved really our uptime and our reliability. So for us, it's key. We have 7 by 24-hour operations, so any outage is a big deal for us, and we have potential of losing millions of dollars per minute. So we are trying to make sure that we're protected. And then for the infrastructure team, they want to have a single pane of glass. So we use VMware at all our refineries. We use it on-prem for a lot of different things. But in the cloud, we also want to have a single pane of glass and bring all of that infrastructure to a single pane. My team is not huge, so making this very easy to manage was very important to us. So let's talk about the challenge. So in 2022, we went through an acquisition right at the end of the year. And so at the beginning of this year, we told investors that we were going to have this thing fully integrated in 1 year. And so that means we are going to have to bring over all of their servers. So we were given 3 months to move 1,000 servers from on-prem in Denver to the cloud. And because of that time frame, we had the inability to do any optimization as part of the process. We were moving like for like, just getting it up. And this is SCADA, pipeline control, legacy apps, their HR, their ERP, everything. So we were having to move that in 3 months. They're a 7 by 24-hour operation, again, like us. So unplanned outages were unacceptable. So we had to do this, making sure that the business continued to operate. There was a lot of data that we had to move. So they had terabytes and terabytes and terabytes of data. So we were having to move that onto FSX, along with trying to move these applications across. Our setup was we had a VPN connection, and we did everything across the VPN IPsec tunnel to the cloud. And so we used Equinix and our on-ramps to be able to get to our direct connects and be able to move those workloads immediately into the cloud. So if we look at kind of our goals, we laid down some basic foundations that we had to live by. So first was we had to move these workloads without changing the IP addresses, without changing their server names, and without removing them from their Active Directory domain. Easier said than done. The great thing is that we had very little IP overlap, which never happens. But in this case, we did not have much IP overlap. So we were able to maintain their servers. We had to build a security boundary. These were still two separate entities. We had to make sure, as part of our goal was we needed to build an inspection VPC and make sure that everything that came across into our enterprise was secure. We also had some OT stuff that was there, so we had to make sure that was very secure. As I talked about this a lot, but there's 7 by 24-hour operations for midstream. So midstream is pipelines, and so they had regulated pipelines and non-regulated pipelines. And so there's a lot of things that we have to consider when we get into the regulated space, especially around TSA. So we're under a lot of audit obligations for TSA. And then as part of this, we also had to maintain their SOCs. So that was our goals. That was the problem that at hand, and we had 3 months to make this happen. So let's talk about what we did. So we started with the published reference architecture, and we did a little modification. As I said, cybersecurity is a big deal for us. Being a Fortune 20 company, we're a target for a lot of folks. So we had to make sure that we maintain that solid security boundary. So if you look at the reference architecture, this is what you'll see on the web. So we do a connection through our transit gateways directly to VMC. When we updated it, again, you'll see, oops, went the wrong way here. There we go. So we added an inspection VPC. And the reason I'm talking about this is because there's some things that challenge us with. We also had our stretch cluster and our non-stretch cluster. So this became our new reference architecture for VMC. The beauty about this is that we didn't have to go and try to rebuild this from scratch. And Andy talked about the difficulty in trying to maintain the entire infrastructure to make this happen in the cloud. If we had to build this, there would have been no way we would have been successful in our journey to the cloud for DCP. So next, we said, oh, well, we'll make this work. We'll use a single cluster. I think we'll be able to fit it all. We'll use the stretch cluster for everything. What we found out is that there are some limitations in the cluster, especially around how much data you can put in a cluster. And we also need to be compliant. So, Oracle's very strict with their licensing model. So we had to build clusters to maintain those licensing obligations to Oracle. So if we go look at kind of the clusters, I'm not going to read this out to you, but you can see this is kind of typically what a cluster looks like. The one thing you need to notice is when you get into stretch, you no longer have 16 nodes that you can deal with. You only can deal with 8. It runs active-active, but you still got to be able to fail across on multiple AZs. So I guess we were not up to speed on that in the beginning, and that's why we thought we could put everything on a single cluster. So we had to build some extra clusters. It's not a big deal, but some of the things you just need to make sure you remember. So we had a solid understanding of VMware. We've been using VMware forever. I mean, like all huge enterprises, VMware is a core foundation. But what we did find out is that there's a lot of little nuances that we were not, I guess, it's not that we weren't aware of, but they came back to kind of bite us when we started doing our implementation. So the first was the MON feature. This is a great feature. This keeps traffic local to the cluster instead of going back to the gateway. For us, this started to become kind of a challenge because we did subnet by subnet migrations. So we could not move the gateway when we started to do our migrations. So we had, I think, 100 subnet migrations that we had to do. And so what happens is with the MON feature, because we had the inspection VPC, we also had the VPN tunnel. It would create what we call an out-of-state network or out-of-state traffic. And because of that, it would start to drop data packets or block data packets. And that became a huge problem because we had a lot of VPNs and we had a lot of other third-party connections. And so trying to figure out every place that MON was being enabled, we had to go and disable it across the board. And even though we knew we had to do this all the time, it still came back to bite us 9 times out of 10. And it's just something you have to watch out for. It's a great feature, but it's something that you definitely have to make sure that you understand. And again, if you're just doing a pure migration, over the weekend, you won't have to worry about this feature. We were doing this over a month period of time, moving these subnets. And so we could not move the gateway. And this came back to bite us.
So Rick, it sounds like the MON feature was incredibly important for actually being able to accelerate the migration. You mentioned earlier you have a ton of data that you have to do, but that security VPC that you were talking about ended up creating asymmetric flows, and it couldn't see both sides of it. So when you say out of state, you're saying like the asymmetric flows were by design, it was important, but it also broke some of the acceleration and optimization features.
Exactly.
But on some of those subnets, it was really important. You needed that accelerated data transfer to be able to hit your deadline, but you also needed to inspect traffic in other cases, and that was more important. So you had to ultimately make those trade-offs and decide on a subnet by subnet basis which ones needed MON and which ones did not.
Exactly.
That's a great lesson. That's a great insight where I think coming into the beginning of it may not have been completely obvious.
Right. So another thing was the way that VMC treats S3 traffic. It pushes it, to the directly connected interface. Again, we had the VPC, we had the inspection VPC, we had to kind of break that workflow. Otherwise, we were starting to get block traffic again. There's a lot of little things about how VMC treats traffic. We use FSX for a lot of our data. FSX uses basically a registered IP address, so it sees it as it needs to push everything out our internet gateway versus keeping it local. So there's little things that that'll catch you off guard, but you can always work around it, and they're not a big deal. It's just things you have to be aware of.
Yeah, I mentioned earlier the whole ability with that ENI to connect across to AWS VPC networks. So if you were to visualize this for a moment, imagine you have kind of an edge device, and that edge device has a connection to your inside networks, a connection to the internet, as well as a connection to the VPCs, to your AWS VPCs. And so in some cases, you actually can make the choice. Do I want to connect to an AWS service through the private link to the endpoint that's running within the VPC, or do I want to connect to the public API endpoint? So if you're familiar with S3, for example, S3 has a public API endpoint for these buckets. You can connect to it just publicly. You don't have to, it's not traversing an internet gateway or coming inside of your VPC. But you can also create a private endpoint for S3 where it can only be accessed, and you can put a bucket policy that says I can only access this bucket from within this VPC. That's just kind of a native AWS capabilities. You can choose to access it publicly or privately. And in the case here with VMware Cloud and AWS, they can make that choice. Do I want to access this publicly, or do I want to access this privately? And those are configuration options you can choose. Actually, within VMware Cloud and AWS, there's an option to select saying, I want to route S3 traffic, that registered IP space that Rick's talking about. I want to be able to route that traffic across the ENI and have it talk privately within the VPC, or do I want it to go publicly? But those are great considerations to think about as you're laying this out or planning it. And I know y'all were moving very, very fast, and may not have been something to catch up front, but something you guys certainly figured out and were able to work with, which is great.
And then lastly, how are we going to do the migration tools? How are we going to make this happen? So when we started out, again, we looked at, we could do backup and restore. 7 by 24-hour operations can't have downtime, too much data. That wasn't going to work. We then started looking at some typical third-party migration tools that we had experience with. Fantastic tools, but the problem was that they weren't certified on VMC, so they needed root access. VMC is not going to allow that, so we had to bypass that. We were probably less familiar with the native HCX offering, but that actually saved the day. The HCX, I think it was coming out of private preview. We were still getting familiar with it, but what it really allowed us to do is do mass copy differentials up to the cloud, and then we would do subnet by subnet migrations. We didn't have to change IP addresses. We didn't have to change our server names. We can keep everything within our Active Directory domains. That was kind of the key to us being able to make that happen. So let's talk about a little lessons learned. First and foremost, the network layer has to be major consideration when you're starting to work on these type of projects. We have some world-class network architects, and they do a lot. But again, if the network layer is not operational and it's not working, you must have the transit gateway, or it's just going to be too slow. So you've got to really concentrate on your network layer. Two, we use direct connects. We have 3 on-ramps to AWS through each of our cloud connects, which is our Equinix facilities. And so that is a major way to gain access to AWS. So the transit gateway gives you 50 gig throughputs, and it does a world when you're trying to do your migrations. We had a lot of VMware skills in-house, and that was great. I think we have more VMware skills now after this project. We really had to learn a lot of new things on the fly. But again, you need to have some VMware skills, especially if you're going to do this in a quick time frame. Subnet by subnet cutovers take a lot of planning. And when I say a lot of planning, like plan, and then have plan B, C, and D when it may or may not work. We were coming into this a little bit blind. It was an acquisition, so until we signed the paperwork, we really didn't have a lot of exposure to their back-end infrastructure. So because of that, we were coming in blind, and so we knew how to do it, but we didn't understand pretty much all of the interdependencies immediately in the beginning. I think if you do have time, using VRNNI or VOps will help you with your dependencies. As the connected enterprise starts to grow and grow, it becomes a spaghetti bowl. And so trying to figure out what servers talk to which other servers, which subnets need to go with each other, that tool was invaluable in helping us try to decipher what we were going to move, especially in the subnet by subnet planning.
Dependency mapping is something that I hear come up from a lot of different customers, and especially when you have to move quickly like this. And in an acquisition where you may not necessarily know what applications are talking to each other, having a tool or having an ability to just figure out what apps are actually communicating with each other, especially if I don't know if the existing environment, were they running NSX at that time, or was it all just standard VMware?
It's all just standard VMware.
Yeah, so like if you're moving from an environment where there's no NSX and all of a sudden you're going into VMware Cloud and AWS where you have NSX, you have an opportunity to put in east-west firewalling rules and actually segment that traffic. But in a lot of cases, you go ask like what's talking to what, and you mentioned 1,000 servers. Like I'm sure that's super difficult, or nobody keeps track of exactly what's talking to what. So being able to do that lay of the land, get an assessment of it, and then bundle those things together to say, oh, these things are going to move in waves or groups. I'd imagine that was a huge benefit.
We got to be experts at diagnosing firewall rules. That helped us a whole lot. Palo Alto and us became very, very close friends on trying to figure out our firewall rules. And then lastly, they were a little bit back leveled on their ESX, so that we had to actually upgrade a lot of their platforms to be able to make these migrations. And so we didn't really think about that. We thought, hey, it's VMware to VMware. We can move these workloads, no big deal. But in retrospect, it took a lot of time and effort to get them so that we could make this migration. So that's kind of our journey that we took. As I said, a lot of people thought it was going to be impossible. I think some of our people thought it was impossible, but they worked a lot of hours. They dedicated a lot of time to make this happen, and we did this in 3 months. And we had about a month and a half of pre-planning, and on top of that, we were doing all sorts of other migrations. So this was just one of the links in the cog that we were doing at the same time. But getting this across made a huge difference, because now we are in the final throes of the integration with DCP into Phillips 66.
I mean, that's an interesting point. Like all these folks who were working on this migration still had their day jobs. Like they were still doing their day jobs, and all of a sudden I could imagine you walk into a meeting and you're like, hey everybody, guess what? You get to migrate 1,000 servers in 3 months. I'm sure everybody was cheering and super happy about that, and they said, yeah, Rick, we got this.
I was unpopular for a while.
It's such an incredible story, and I mean, really just think about it. If you had somebody walk in and say, we're acquiring a company, you have to move 1,000 servers in 3 months, and you still have to do the day job that I'm sure was not like you were sitting around playing solitaire all day to begin with. Like, this is a monumental undertaking for that team, and all the planning, and you mentioned the kind of like all the little gotchas. I love that Rick can come up here and share with you the reality, the real world. We can talk about this is the way it's supposed to work all day long, but it's such a gift to be able to hear from somebody who's lived through this and said, hey, here's the reality. Like, be sure to make sure you think about upgrading ESXi in the source environment. That may not have been something to think about, or IP overlap, or the firewall rules and grouping. Like, these are really great things to hear that hopefully will shed a lot of light on folks who are thinking about using this type of approach in their migration.
Yeah. So VMC saved the day, and it continues to be our go-to for all of our production workloads. So I guess I'll hand it over to you.
Yeah, thanks, Rick. Really appreciate that. Yeah. Wanted to talk a little bit about next steps. If Rick's story was interesting to you and what his team was able to accomplish sounds like something that may be valuable in your space and in your use cases, I wanted to leave you with a little bit of next steps. Like, what are some things that you should be thinking about as far as getting started or learning more or just diving a little bit deeper? There's other sessions throughout the week that talk about VMware Cloud and AWS. There are also the VMware booth in the expo hall. Stop by, talk to those folks. They have some demos set up where they can actually show you the environment. But seeing it and hearing about it is one thing. I would say there is no substitute for real world hands-on access and real world results. Being able to put this in your team's hands, in your hands, and actually try it out and see how it truly works. What's great about a cloud environment is, we talk about being able to use it for experimentation. That is a major thing that folks do with AWS, and that's where a lot of innovation comes from. Being able just to try things out, test it, put your hands on it. You're not investing hundreds of thousands of dollars in capital to go do an experiment for a week. You can fire it up, turn it on, try it out, turn it off, turn it back on again if you want to try something different. I highly recommend, if this is, just give it a try. Just actually go in and fire up a VMware Cloud and AWS environment. You can spin up an environment, you can deploy VMs in it, you can connect it to a test or a lab environment on-prem, and then migrate a virtual machine. Set up HCX, migrate a virtual machine. The setup of the network bit is really where a lot of the lessons come from. Rick was mentioning, one of the things his team had is like the networking expertise, and like working through the networking bit is super important, and I completely agree with that. I hear customers say it took us a few days or a few weeks even in really complex environments to get the networking stuff figured out, to get the connectivity established, and quite honestly, moving the virtual machine was like a right click and a go. Like, that part of it was so anticlimactic. Actually moving the bits over, it just kind of worked. But we did have to spend a few days or a few weeks in really complex environments getting the networking stuff figured out, getting the prerequisites and the connectivity put into place. And I encourage you, if you have like a test environment or something that you can just try as an experiment, go spin up an environment, give it a try, kick the tires and see what you think about it. And then when you're done, you can destroy the environment and turn it off. There's no long-term commitment for this, just to experiment and try it out. We do also see a lot of customers use VMware Cloud and AWS for kind of temporary life rafts for environments that they need to make changes for. I've seen customers actually they're doing power maintenance, or they're doing some kind of environmental maintenance in an on-prem data center, and they would spin up VMware Cloud and AWS, migrate their workloads over as a temporary housing location, and they would completely tear down their on-prem environment, rebuild it, move things around, do the physical work they needed to do, and then move back. Like, how many times have you had teams internally say, man, I wish I just had a temporary cluster for a few days? And this is a case where that can be useful as well. Also, just in the case of like bursting or expanding environments, we see folks do this a lot as well. They have an on-prem environment, they're depreciating it over a long period of time, so they're not interested in migrating today, but they have a big event coming up. Think of like an organization that is big around the holidays, or big around a particular sporting event or something like that, where they need additional capacity. But they already have their templates and their tooling, and everything is already built around the VMware ecosystem. Being able to actually spin up an environment and expand and burst into the cloud, have that elasticity of, hey, if I need to add a host to an environment, I click a button, and within about 10 minutes, I have a host available. It's ready to go. It's ready to operate. Contrast that to an on-prem environment where you have to buy a server, wait for it to show up, rack and stack, burn it in, configure it. That is a weeks to months operation, whereas getting a new server in a cloud environment is a single-digit number of minutes operation. So being able to use this as a burst use case. So I encourage you to think about ways that you could experiment, ways that you could just kick the tires and leverage this. You can read about it all day long, but there really is no substitute for just giving it a try and actually seeing real-world results. One thing I would recommend is, I'm sure, Rick, you also had this happen within your organization, but you really have to bring the teams together around this. If you have kind of siloed teams within your organization where you have a networking team, a security team, you have a vSphere team or a compute team, and all those teams are completely independent, it is very, very important to bring those teams together and really have them work within a cloud center of excellence or form a cloud center of excellence. If you are moving into a cloud environment, there's so much more that you can do with integrating into native services and taking advantage of all the native capabilities within AWS. One of the first things I recommend folks do is don't let VMware Cloud and AWS be a siloed project for the compute team. You really do need to bring a team together, have representation and folks from the security team, from the networking team, from storage, from all those different parts of the organization, compliance, everyone. You really do need to bring those teams together and have this be a joint initiative, a joint effort. That way they can all be a part of the transition and all have a voice in the configuration. I have seen it, honestly, the political aspects of this where one team has built it and they've made it work, and then they didn't bring in the compliance team early enough, and so now it delays migrations and delays projects just because they're trying to bolt that on at the end. That can be a real challenge. So bringing in those teams early is super important. Bringing the group of folks together is critical. Proof of concept environments, I mentioned, these are just, I can't say enough about them. I hear so much feedback from customers saying, I met with my solution architect, I met with VMware, we heard about it, yeah, it made sense, everything seemed great, but we really didn't get it. The light bulb truly didn't go off until we did that first virtual machine migration. And when we moved it over and we saw it in action, that's when it really clicked for us. And that's when we started thinking about all kinds of other things that we could do. So I can't say enough about deploying a proof of concept environment and actually trying it out. And I get that migrating a workload may not be, migrating a real production workload is probably not the safest thing to do, probably not the thing you want to test with. So I always encourage folks, if you have a lab environment or a demo environment, a dev test environment, grab some non-production workloads and let that environment be your test case. Or stand up synthetic workloads or synthetic VMs if you want to test in that way. But actually test with something real. Find something that is meaningful, that you can actually have performance indicators before and after, and you can see those results and measure those results and be able to report on that. I also wanted to share, we announced this week here at reInvent, we made an announcement earlier that we have launched a new instance type. So I mentioned earlier that the VMware Cloud and AWS runs on AWS bare metal instances. We have a few different instances that are out there. Rick mentioned the i4i instance, and he showed the page with what the specs on that look like. We also have the i3EN instance that we operate today. And we have announced earlier this week the M7i Metal 24XL variant. So with M7i Metal, we actually have a couple different sizes of metal instances there. And the M7i 24XL instance was announced this week. What's super interesting about this, for those who are familiar with vSAN, the way vSAN works is it actually aggregates the local storage within the physical server itself. So you have local instance storage, and vSAN aggregates that together and forms a distributed data store. So if you want to add additional storage, you add an additional compute node, and you scale compute and storage together linearly. With the M7i.metal 24XL instance, we are not using vSAN for local instance storage in this particular case. In this case, we are using external storage, the FSxN. That is an external file-based storage solution. So if you're familiar with NetApp ONTAP, this is the AWS FSx version using NetApp ONTAP. And so you have decoupled storage from the compute. And you can see the instances themselves are a little bit smaller in size than what we have with the i4i. So i4is are much larger instances, much more memory and CPU capability. The M7i.metal is a much smaller instance. This is really great for proof of concept testing as well, if you want to test with a much smaller instance. And since it allows you to decouple the storage from compute, if you need a really small compute footprint, but you have a lot of storage, this allows you to scale that storage independently of the compute. Whereas i4i is going to be a much beefier, more powerful instance, but it's going to have compute and storage scale linearly. And the same thing with i3-EN. i3-EN is a much more storage-dense instance, so it has a lot of local instance storage, and it's a great use case if you need kind of the performance of local NVMe storage aggregated with vSAN. That is a great instance to use. So the goal here is to give you choice. You have multiple instances to choose from. You can pick the best use case or the best instance for your particular use case, and you can deploy multiple clusters. So you could have a cluster of i4i metal instances. You could have a cluster of i3-EN instances. You can mix and match. And the same thing is like what Rick mentioned. They mixed and matched where they had one cluster that was stretched across multiple availability zones. So you're actually taking that VMware NSX environment and the storage environment, and you're stretching it across multiple availability zones. So that is a really interesting option because not everything is sitting within a single AZ and you're having to replicate it out. In this case, the cluster is stretched and VMware's taking care of replicating that and making sure the network is coherent across both AZs. And then you can have the non-stretched version where it's just isolated and independent within an availability zone. So you can have multiple instance types per clusters. You can have, multiple instances that form a cluster. You can't mix and match, so you can't have an i3-EN with an i4i in the same cluster, but you can have different clusters deployed, and then you can have those clusters in both a single AZ and a stretch cluster configuration. With that, we are available to answer any questions. So we were shooting for about 15 minutes left that we could shoot down here or sit down here and answer any questions. We're at 14 minutes. We made it. That's a win. So we'll say thank you. We'll be down front if you'd like to come up and ask any questions. Really appreciate you taking the time to join us this morning. We hope this was informative. I would ask, if you have a few minutes, please take a moment to open up the app, fill out the survey, let us know what you liked, if there's something that we could be doing better in the future. That information, that feedback is so critical to us. That's how we choose what sessions we're going to be looking to do in the future and what topics are most of interest to you. So if there's an area that we could focus on more that you'd like to hear more about, please give us that feedback. We'd really appreciate it. I hope everybody has a great rest of the show. Thank you so much for joining us. Have a good day.